Hello everyone and welcome to lesson 22 of the Safe Math STEM Physics channel. This is the last installment of the wave interactions part of the AQA A-level physics course, and today's lesson is about harmonics. So what is a harmonic? It is at what frequency a certain type of standing wave will form. So a standing wave of which has one antinode will form with the first harmonic. A standing wave which forms with two antinodes will be at the second harmonic. And so the first point that we need to know is n antinodes equals Fn, frequency n, not frequency multiplied by n. It's just the nth frequency, which is the nth harmonic. Now, if it has one antinode, then between these two given points here, we will have a standing wave like this, and obviously we denote the bottom half with a dashed line to show that it will go down there, and the antinode is those 2 points there, or what's basically the same point. And those are the points of maximum possible displacement. That's what an antinode is. And so it follows, and that would be F1, sorry, and F1 corresponds to what we call the first harmonic or the fundamental harmonic. Now, if we have F2, it will look something more like this. Now, these drawings should actually have the same length. So I'm just going to actually scribble that out and redo it for you guys. Because they should be roughly from the same string, same piece of string that they're forming on. And I know these diagrams are shoddy, but you're getting the gist, I hope. And so we do have a formula for the frequency for a harmonic on a string, and that is F1 equals 1 over 2L multiplied by the square root of T over mu. And so there's some stuff that you probably aren't familiar with there. L is simply the length of string. T is the tension in the string. So if I was to draw out the full diagram just on here, we would have a signal generator causing this to oscillate, and then we'd have a pulley system leading over here, and we'd have some masses here. The weight on those masses is equal to the tension in the string. That's where the tension comes from. And mu is the mass per unit length, not the density, the mass per unit length. So you're just dividing it by the length that you have, not the volume that you have. And that's the equation for fundamental frequency. It's then quite simple from there, because to get from F1 to Fn, you just multiply it by n. So n F1 equals Fn. So just to give an example, 3 F1 equals F3, or which would look something like this. Which would look something like that. Sorry, you can't really see the bottom of my screen there. That's what F3 looks like. And that is incredibly short of a lesson, but I hope it has been very helpful for you guys. And thank you very much for watching. I will see you guys in the next one when we finally move on from waves. Bye.